Okay, everybody. It's pretty late at night. It's about 1 in the morning. Everybody's sleeping, but I was kind of awake, and I figured I'd make a couple videos just to pass the time and free up some time during the day tomorrow. But anyway, one of the things I wanted to quickly go over again was this concept of relative humidity. And in one of my other videos, I mentioned that relative humidity can be shown mathematically. And I can put an equal sign there. And I could say relative humidity is equal to the actual water vapor in the air divided by the capacity of the air to hold water. Now remember, the capacity of the air is dependent on the temperature of the air. And this is one of the problems with relative humidity, is that it can change due to an actual change in the amount of water vapor, but it could also change due to a change in temperature, or even a combination of the two, which makes relative humidity a little bit tricky. And this is why I like dew point better. Dew point is not affected by temperature the way relative humidity is. A year or two ago, I was checking the weather in the wintertime and noticed something kind of interesting, and it was interesting to me, so I saved it. Let me see if I could find that really quickly. So, let's see. Okay, so here's a weather forecast from a while ago. Okay, so this is an older one, and we can see the date. This was February 13th, okay, so right before Valentine's Day. But this was, I believe, 2 years ago. Yeah, so it was a couple of years ago, if I remember right. And yeah, February 14th, we got a big snowstorm. Now, if we take a look at the conditions, what's kind of interesting, to be honest with you, I haven't looked at this in a while, but I found it so interesting that I saved it. I set it aside. I did a screenshot of it. Here we have a relative humidity of 74%, pretty high humidity. But if you remember, this was from a couple of years ago, and around this time there was a lot of talk of what was called a polar vortex, and that was a big news item at the time. Maybe you remember that, probably not, but maybe. We can see these air temperatures though. Air temperature of -12, okay, so it was very, very cold at that time. We have a dew point of -18. A dew point of -18 indicates incredibly dry air. Okay, it was very, very dry air on this day, February 13th. I think it was 2014. Anyway, very, very low dew point, very dry air. But if you look at the humidity is all the way at 74%. So it's kind of contradicting. The relative humidity suggests humid, moist air. 74% is pretty humid air. But the dew point, -18, suggests really, really dry air. And the reason for this is the air actually is very dry. Remember, dew point is a more accurate measurement of humidity. The relative humidity is artificially high because the air temperature is so low. And with an air temperature of -12, the capacity of the air to hold water is really low. And since the capacity of the air is really low, if we go back to our fraction for a second, and if we have a very low capacity of the air to hold water, that's essentially decreasing the denominator in a fraction, which is going to make the relative humidity higher. So in this example, we're looking at from February 13th, 2 years ago, we have very dry air, but the humidity isn't really real. It's saying 74%, but that really doesn't make much sense. That is the actual relative humidity, but it's kind of not very meaningful. It's not really giving us a real indication of how much moisture there is in the air. And that's one of the flaws with relative humidity. And again, sometimes people ask me, well, why do we even use it? If it's flawed like this, and I really think it just comes back to people like percentages compared to something like the dew point temperature. It's just not as very easy to understand. This was a couple of years ago, but there was a very large snowstorm on Valentine's Day couple of years ago, if you remember that. I think we had a snow day. I think we had maybe even 2 snow days out of this storm. I think we were off Thursday and Friday, if I remember right. And we had probably close to 2 feet of snow accumulation from that storm. But anyway, the real reason I say this was the humidity here. So kind of an interesting thing about relative humidity compared to dew point. Dew point is always a better measurement of humidity, moisture in the air. All right, I'm going to make a couple other videos tonight, I think, too. Air pressure and cloud types, probably. So I'll be back soon. Okay, good luck.